All right, so these are informal rules. They're not the formal ones, but I find these probably easier to remember and easier to use, okay? I sometimes call them the thou shalt nots. So zeros are not significant if they're supposed to be rounded off. So if we already talked about rules for rounding off in multiplication, division, and then a separate set of rules for addition and subtraction, if we've already talked about digits that have to be rounded off, zeros aren't significant if they're supposed to be rounded off, okay? All right, leading zeros, those on the left side of a number, okay? Since we read from left to right, the ones in the front are the leading ones to the left. Those are insignificant. And the zeros on the right are insignificant, but only if there's no decimal. Okay? So let's talk about some examples here, though, okay? Let's see. If I'm adding up some numbers, let's do 12.624 grams of something and 1.4962 grams of something. Let's just say we're going to be doing gold. Okay, so we add those together. We got a 2 here, a 10 here. That makes that a makes it a 12. So that's 11, then 14. Did I do it right? Okay, so I have one empty slot over here on the right, and so that means that 2 has to be rounded off. So 14.120 grams of AU. That zero is significant. Oh, I'm sorry. That zero is significant. Okay, we didn't round it off. Got it? All right. Now, if I do 3.47 and 1.583 and 0.117, and then we'll make this milliliters of mercury. Okay, we'll add all those up, and we get a 10 here. That becomes a 16. That becomes an 11, 4 and 5, I believe, millimeters of mercury. Okay, so now we got an empty slot here. All right, so the rules say this digit has to be rounded off. So no matter whether it fits any other rule, if it has to be rounded off, it's not significant. So that's applying. All this is applying to rule number 1 up here. Okay, does that make sense to you? Just giving you examples for zeros that have to be rounded off or not rounded off from the other rules. 5.16 milliliters of mercury. Okay? You understand what I'm saying? Not hearing anybody. I guess you're just writing notes because you can't think and write at the same time?
Right. You're going to
Well, what are you going to do in college? Where the professors are just going to keep right on talking whether you're keeping up with them or not. And you really think you're going to have time to listen to the recordings? Huh? You know, the rule of thumb is if you're going to be in college, you can expect to do, and this is without listening to recordings, you can expect to do 3 hours of work outside of class for every 1 hour in class. Okay? That's homework, research, various things like that. Add it all up. And if you're going to be successful in college, you can expect to do 3 hours of work outside of class for every 1 hour in class. Okay? So, yeah, I guess most professors probably wouldn't mind. Some would. Some would say, no, you can't record. And in college, the professors have a lot more power in terms of setting rules for their class than I do as a high school teacher. So if they say no, it's no. There's no appeal. And they have a right to kick you out. If you violate their rules, you're gone. Okay?
Free money.
Huh?
Free money.
Free money? Oh, for the school? Yeah, well, that's true. Because if they kick you out for violating rules, then you can't get a refund. You know, that depends. The rules, schools always have rules about when you can withdraw and still get your money back. They usually do that, but at a certain point in the semester, you know, you can't get them back. Okay. Now, you can go back and ask the professor to let you back in. You know, they might do it, they might not, depending on the severity of the situation. And you can try appealing, but typically the professor's, you know, in charge. Okay. I know professors that, you know how students tend to chat in class and not pay attention. I know professors that have kicked people out of class for that. Just kick them out. Don't come back until you can be quiet. Pay attention and participate. You know. All right.
So how much work did you say that you have per hour?
The rule that I've heard is that, and I followed this rule when I was in college. Okay. When I added it up, yeah, pretty much. And it doesn't apply to every single class, but if you average all the classes out, I did about 3 hours of work outside of class for every hour in class. Reading, studying, doing homework, doing research work. Okay?
So when you party?
I was thinking that.
Well, let's try to remember partying is gravy. It's not the meat and potatoes of going to college. Okay? All right. So I could show you also the same sort of thing for multiplication and division here. I'm just giving you an example for addition. Okay? That the zeros that have to be rounded off okay, you can't apply some other significant zero rule and say, well, that's significant, I don't round it off. No. If you're doing multiplication division, or if you're doing addition and subtraction, if the rules say you round it off, it's rounded off as not significant. That makes sense? Okay. So I'm trying to avoid some confusion. All right, so here's an example, or maybe two, for number 2 here. Let's say we've got this number. All right. According to rule number 2, leading zeros, those to the left are not significant. How many significant digits in this number then? 1, 2, 3. The zeros are not significant because they're to the left. There's how many significant zeros? I mean, how many significant digits? 3 significant digits, okay? Now I'm going to use the shorthand SF. SF in plural is SFS for significant figures. Sometimes you use the word significant digits, sometimes significant figures. It kind of means the same thing, okay? And if I have how many significant digits in this number? Just 2, right? All right, does that make sense? All right, so here's the example number for number 3. Go it up a little bit. All right. How many significant digits in this number?
4.
Just 2. Okay, and here's why. If there's no decimal, and there's no decimal in this number, then the trailing zeros are not significant. Okay? Does that make sense? Got that? All right. But if I do this, now there's a decimal place. So we have no rule for insignificant digits here at all. How many significant digits in this number?
3.
4. Both these zeros are significant because there is a decimal place. Trailing zeros are significant. That makes sense? Okay, so this has 2 significant figures, and this one has 4 significant figures. That make sense? All right then, everybody got that written down? Okay, so let's go and look at the formal rules then. Okay, I find these informal ones easier to remember and use. You might like the formal rules. Okay, so significant zeros here. So here's the formal rules. These are the thou shall. Okay. All right. Now there's two rules for significant zeros. One of the rules has two parts. One of the rules has one part. Okay. So I'm going to start with what I call the one-part rule. Okay. In the one-part rule, any zero between two significant digits is significant. It'd probably be easier to remember that if I said any zero is significant if it's between two significant digits. It's just an easier way to follow what the sentence means. Does that make sense? If you'd rather write it that way, any zero is significant if it's between two significant digits. All right? Clear enough to you? All right. And then we've got that two-part rule. So the second rule is I call it the two-part rule. So in the two-part rule, you have to meet both conditions for it to be significant. A zero has to meet both conditions to be significant. Any zero is significant that should be if it both. Okay. And that's going to be, the first part is, if it both follows a decimal place, or decimal, and then and 2, it follows a non-zero digit. So there's kind of an aside to this that may help you understand that you need to know. Any non-zero digit, that you don't have to round off is always significant. Okay, so that's why we only have significant digit rules for zeros, because the non-zero digits don't really apply to most of what we're trying to figure out. Okay? Alright, so let's do an example for the number one for the one-part rule here. Okay, example for number one. 12.0700. Let's say this is marbles. Okay. Now here's where it becomes a little bit tricky. Okay. Marbles is counting. Okay. And counted numbers are infinitely significant. Does that make sense? If it tells you it's marbles, you know from everybody knows what a marble is, right? If you don't know what a marble is, tell me now. Okay? So it's just a round piece of glass, right? All right. So if it's a counting number, all the digits there are significant, regardless of any rules. Okay? So our significant digit rules only apply to measured or calculated numbers. Does that make sense? Remember when we did we're doing multiplication and division, we said we're going to look at the measured or calculated numbers to figure out the significant digits at the end? Well, it kind of applies here too. Counting numbers are always infinitely significant. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 students in here, and that's infinitely significant. Okay? There's no decimals. You can't even have 12 and a half students. Can you? You know? I mean, that wouldn't work. You can't be a student if you're in half anyway, right? Because you wouldn't be alive? Right? Okay. All right. It's a joke. I know it's a bad joke, but it's a joke. It's okay. All right. So let's do something that is measured then, okay? Let's say we have 120,700 kilograms of diamonds. I got somebody's attention. Okay. Now we've got a measured number. Okay. The significant zero rules applies to a measured or calculated number. Okay. Let's look at the number then. We've got one number according to the one-part rule here. Any zero between two significant digits is significant. So this zero, I'm going to draw the arrow here to show, this zero is significant. All right. Because it is between two significant digits, and they're significant because they're non-zero digits. Does that make sense? If you're not clear on it, please tell me so I can try to help you. Okay? All right. Now these two zeros down here, they're not going to be significant. They don't meet either one of our rules for significance. Okay? They are not between two significant digits. And while they follow a non-zero digit, the two-part rule says they have to do both, follow a non-zero digit and a decimal place. So while these follow a non-zero digit, they don't follow a decimal place. There's no rule that makes those significant. Does that make sense? If we go back and apply our informal rules, trailing zeros without a decimal place are insignificant, right? So apply either set of rules, you're going to get basically the same answer. Got that? Any questions about that? We're okay? All right, so let's do an example then for number 2. Actually, this one kind of applies both 1 and 2 here. Okay. Oh, okay. Here we go. So let's take this same number then, 700 decimal place 0 kilograms of diamonds. Okay. Alrighty then. So, is this zero significant now? This new zero I added?
Yes.
Okay, it is because it both follows a decimal and it follows a non-zero digit. It's to the right of a decimal place in a non-zero digit. So this zero is significant. Okay? Now because this zero is significant, these two are significant because they're between two significant digits. That zero is significant, the non-zero digit 7 is significant, so both of these are significant. And this zero here we said was significant earlier because it's between two non-zero digits. Okay? Does that make sense?
I'm kind of confused.
Okay? Okay. So tell me what you're confused about. Do you see more examples?
I just don't feel like when you know if it's significant or not, like the zeros.
Well, first thing you're going to have to memorize the rules. Okay? Until you memorize the rules, it's going to be hard to apply it. Okay? Because we've kind of given you either 3 informal rules or 2 formal rules. Either one covers everything there is that I can think of. Okay? So let's just start throwing out some other examples. Okay? All right? I'll write down some numbers. You can converse with a neighbor if you want to until you figure it out. And then we'll see how many significant digits everybody thinks we have. Got it? All right. Yeah. Now, PA is something you're not familiar with yet, but I'll just so you know, it's a symbol for pressure. Okay. When you think you got it, raise your hand. When you think you know how many significant digits there are, raise your hand. Oh no! I got one. I got a hand back here. I see 2 hands, 3 hands, 4 hands. Okay, we're getting there. 5, 6, 7. Okay, good. Well, Kumar, you raised your hand first. Can you tell me how many significant digits there are and explain why?
Yeah, 2 and 1 is between 4 and 5.
The 0 between 4 and 5 is what? Significant?
Yeah.
Okay. Are there no other significant digits?
Between 0.4.
You think that's significant? Okay. All right. And then what about these 2 over here? Not significant or significant?
Are they? Because they follow a decimal and the digit.
That's true. Okay. So you've left out, in your thought process here, you kind of left behind one of the rules. Okay. So these 2 digits here follow the 2-part rule. They're to the right of a decimal place, and they're to the right of significant digits, these non-zero digits. So these 2 zeros are significant. Oh, I'm sorry. These 2 zeros follow a decimal place, and they follow. That means when I say follow, I mean to the right. Okay. So these 2 zeros are to the right of a decimal place and to the right of significant digits, and that's the 2-part rule. The 2-part rule says when that happens, those are significant. Okay? So those 2 are significant. All right? Thanks for being brave to speak up. All right? Don't be afraid of being wrong, guys. That's how you figure out where your thought process is wrong. We sort it out by you saying, you give me an answer, then I can help you figure out where you're thinking incorrectly. Does that make sense?
So they're all significant?
Well, that's a very good question. Are all the zeros significant? Which ones are not? The first 2 are not. Okay? If we go back to our informal rules, we said leading zeros are not significant. And those are leading. They're out to the left.
How is the first point 0 not significant because that's supposed to be completely different measurement?
You got it. Very good. Okay.
Instead of
There's a
point-
difference.
instead of point 40, that's like point 40.
You're right. So if we take out that 0, if we take it out, then we change the value of this number. We change what's called its order of magnitude. You're absolutely right. Okay? But there's a difference between significant digits and placeholder zeros. Okay? And these are placeholder zeros. Okay? Let's write this number in scientific notation to help see why they're significant and they aren't. Or in this case, they aren't. Okay? So if I write this in scientific notation, do y'all remember scientific notation?
We don't want to read.
Yeah.
Haven't gone over it ever?
We did
Oh, yeah,
once.
I have.
Okay. Does anybody remember how to do that?
Uh,
All right. Let me give you the quick rule. With scientific notation, you put the decimal to the right of the first non-zero digit. And then you multiply the number times 10 to some power to keep the correct, what I call the moment ago, order of magnitude. Okay? So if I'm going to move the decimal place here to the right of the first non-zero digit, well, that's my first meaning going from left to right, like we read. Huh?
So then you do it 10 power?
Yep. So I'm going to move this decimal place here. Let me make it a little darker so everybody can see what I'm doing. There's the decimal place. I'll move it 1 place, then 2 places, okay? if I move it 2 places, then what I get is 4.0500 times 10. Now I have to have a times 10 to keep the value of the number, the order of magnitude right. Okay? We can't just say 4 because 4 is nowhere near the same number as 0.04, right? So we have to multiply it by something that keeps the value right. And that's times 10. Since I moved it to the right 2 places, it's 10 to the negative 2. If I move to the right 2 places, 10 to the negative 2. If I move to the left, it's a positive exponent. Okay, and that's KPA, or PA here, okay? Now, since that's writing it in scientific notation, those zeros are clearly not there. They're not significant. Does that make sense? Okay, so order of magnitude zeros, or place keeper zeros you could call them, aren't necessarily significant. Okay, that's a different thing. Significance is different from order of magnitude. All right, without trying to be too complex about it. You got that? Okay. So the leading zeros are not significant. We've got 3 significant zeros, 2 insignificant zeros, and a total of 5 significant digits. Okay? Y'all with me so far? I'll begin to clear the fog a little bit, maybe? Okay, let's try another number. Okay, 37,000 kilograms of brass. When you think you know how many significant digits there are and can explain it, raise your hand. Got one hand over here? Do I see 2? There's 2. Anybody else? No? Just 2 people think they can figure it out? You got scared now after you saw the last one? All right. Tell me how many significant digits I have. None? Okay. You differ with that?
I think that there's only 2 significant digits.
Okay.
Zeros are insignificant.
The zeros are insignificant, and the non-zeros are significant. Okay. Why did you think there were no significant digits? Oh, there are no significant zeros. Well, so both you're right. You just misstated what you meant, right? Yes. Okay. So the zeros here, if we're going back to our informal rules, there's no decimal in the number, so the trailing zeros are not significant. If we're using the significant zeros formal rules, then neither rule makes these zeros significant. They're not between 2 significant digits, and they don't follow a decimal place and a non-zero. They have to do both. Okay? They follow a non-zero digit. But they don't also follow a decimal place. So these 2 zeros are not significant by either rule. Okay? All right. So here we have no significant zeros. All right. Now, do I need more examples, or are you guys kind of on track here with this? Kind of on track? Do you want me to give you some more examples or not?
Would you write it as 37 times 10 to the second?
3.7 times 10 to the third. Okay. What he's asking is, if we're writing it in scientific notation, how would it go? Okay. Well, I got to have my decimal place just to the right of the first non-zero digit. That's this 3. So if I have to move it to the left 1, 2, 3 places, then my exponent is a 3 on the 10. Okay? So that becomes then 3.7 times 10 to the third power kilograms of brass. Okay? All right. Yep. Now, scientific notation makes writing really big or really small numbers a lot easier. Okay? And that's what makes it convenient for us. Okay? Scientific notation makes writing numbers convenient when they're really large or really small. Okay? I'll give you an example of that in a minute. But there is one case where you have to write a number in scientific notation. Okay? Let's put it in black here. Scientific notation is required when digits in the ones place must be rounded off. Okay? Scientific notation is required when digits in the ones place must be rounded off. All right, so let's do one more example here with significant zeros to see if we can kind of sort out what's involved here, all right? Parsecs. I think that's the right spelling. I don't use distances in parsecs very much. That's like distances in space, really long distances. Okay. All right. When you think you know how many significant digits there are, let me know. Raise your hand. Huh? How many? There's 4 significant digits?
6. 5 or 6.
Now, all the digits in this number are significant.
10.
Okay? All the digits in this number are significant. Okay, here's how you know. These 2 numbers here are significant because they're non-zero, right? These 2 numbers here are significant because they're non-zero. And all the zeros are in between. That makes sense? No, if you've never used it before, it's hard to remember all that stuff and use it right away, okay? But we're going to practice with it over and over and over again in this class, because every time you write a number or you round off a number, you got to know what significant zeros are, okay? The addition and subtraction rules, multiplication division rules for rounding off, the significant zeros rules, they apply to this class from now to the end of the class. They'll apply in every chemistry or physics class you take after this one. They'll probably apply in any biology class you take after this one. Okay, if you have to do those kind of calculations in biology, you don't do them a lot in biology, but if you're doing higher level biology in college or sometimes some biology classes, even like if you're taking AP or something, those or higher end classes, you might have to do some of those calculations. So it's important to know what the digits are that are significant. Okay, it's important to know that you can't add zeros on the end of a number to add them for convenience, because then you're lying in science. You're lying about the precision of that number. So we have to be careful about putting extra zeros on there when they shouldn't be there. Okay, that's part of getting the numbers to have the correct amount of significance. Okay, to have the right precision in a calculated answer. Okay, you with me so far? All right. Let's give you. We started making out a homework list, so let me give you some homeworks on having to do with significant zeros then, okay?
Is this tonight, Homer?
Yeah.
Take it.
Say what?
Or do we put tomorrow's date on it for tonight's homework?
It's due tomorrow, but you can put today's date on it, okay? Those 2 different words are almost kind of together here too. There are. I guess that's enough. So that's kind of a lot of writing about each one of them to indicate which of these are zero, whether the zeros are significant or not, and why. Okay. So I figure if you do that for every one of these problems, then you'll have a pretty good idea of, by writing it down each time, you're reminding yourself each time you write it down what the rules are and applying them. Does that make sense? Okay.
You want us to write them down and try to get the
No, I'm just asking you to identify which zeros are significant and which ones aren't, and how many total significant digits there are. That's all I'm asking you to do. Okay? So you're going to say we have a total of X number of significant digits. In this case, you'd say the zeros after the decimal place are, and then tell me whether they're significant or not and why. Does that make sense? And these zeros here, you tell me, on this number, you tell me how many total significant digits you have, and then you're also going to tell me why these zeros are either significant or aren't. Does that make sense? Okay. Any other questions? All right. Huh? Yeah, we got some more time. I got more to cover. I'm just writing down the homework as we finish each thing we're working on. Yes.
I have my homework
From what?
yesterday.
Has it got yesterday's date on it?
Yeah.
Okay. Were you absent yesterday?
No, I came in late.
Oh. All right. In the future, when you come in late, you have to do a makeup homework. Okay, you have to come and see me for makeup homework. I'll accept it this time, but you know, that because you could have. I mean, I don't know that you didn't see somebody's solution overnight. You know, you said because everybody took down the work yesterday. See. Okay. Yeah. I haven't made out the notebook for you to sign in yet. I need to get that done. So just take the pass with you.
She wasn't absent yesterday.
Huh?
She wasn't absent yesterday. She just came in late.
Oh, right. Okay. Well, again, I mean, you're sitting right in front, I probably would have noticed, but somebody sitting in the back, I wouldn't know, you know, so. I took up everybody else's when they came in, but I guess I just didn't ask you for yours. So in the future, when you come in, that's the first thing to ask, okay? Okay. You left off a decimal place. Let's see, what was the total? 32 points was the total for everything? Okay, you got it. All right. So that's significant zeros. All right, I want to talk a little bit about, sort of in preparation for tomorrow's lab, the way that you're supposed to handle formal tables and formal graphs. We're going to start with formal tables, okay? We may not get through all of this today, but we'll cover the remainder of it tomorrow as part of the lab, okay? Okay. So typically, formal tables are not required in your lab logbook. They are required when you turn in a post-lab report. Let's see here. I wish I had some numbers I could just pull out that I knew for sure were accurate, but that's okay. I'll just make up something here. I should have thought about this before I started giving you notes on it and printed it out this morning, but that's okay. Let's see, I need to stop this because this is not part of what I was